Hi everyone, I'm Yuvashri from second year CACB department in Kongunadu College of Engineering and Technology. Here I am going to show the PPT and explain the topic of CPU scheduling algorithm in an operating system. The CPU scheduling algorithm in an operating system maximizes the system efficiency through the smart process management. Here is a small introduction about the CPU scheduling algorithm. The CPU scheduling algorithm determines the order of process execution in a multitasking systems. Its main goal is to minimize the waiting time and improve the CPU utilization and ensure the fairness. The essential for CPU scheduling algorithm is used in an operating system, cloud computing, real-time systems. In an statistics of 2023, the efficient CPU scheduling improved the system responsiveness by 50%. The CPU scheduling algorithm is important or not. The need for CPU scheduling algorithm is maximize the CPU utilization, reducing the waiting time, enable multitasking, prevent starvations. Maximizing the CPU utilization is nothing but ensure no CPU cycle are wasted. Reducing waiting time, it fosters the responsible for the user's programs. Enable multitasking, a multiple process run smoothly. Prevent starvation, ensure that the fair allocation of a CPU resources or not. Statistics. As per the statistics in 2023 in an Intel's, poor CPU scheduling can cause a 30% performance drop in a multi-core process. Types of CPU scheduling algorithm. There are majorly two types of CPU scheduling algorithm, namely preemptive scheduling and non-preemptive scheduling. Preemptive scheduling is nothing but once the time completed, the job gets stopped and move to the next job. Non-preemptive is nothing but it's wait till the entire jobs get completed. As per the statistics in 2023 regarding to the Microsoft, 90% of the modern OS use a preemptive scheduling for better responsiveness. First come first serve scheduling. The process are executed in an arrival order as a first come first serve approaches. This is a basic concept of queue. The first come only the first serve for the queue process. The simple but can lead to the long waiting times and conveyor effect. For example, P1, P2, P3. The first come order is P1. It's not about the MS time, it's about the what come first. The P1 come first, so P1 taken as a first waiting time and P2 second and P2 taken as a second waiting time and P3 third and the P3 taken as a third waiting time. This is what the first come first serve approaches. FCFS increased the average waiting time by 40% in mixed workload as per the statistics in IBM 2023. Shortest job first in a short form is called as SJN schedulings. It executes the process at the shortest CPU burst time. Burst time is nothing but the time required by a process for the CPU executions. It optimizes the average waiting time but can cause a starvation for a longer process. For example, P1 is 8 ms, P2 is 4 ms, P3 is 2 ms. The waiting time of P3 is 2 ms. So we taken the P3 as first and the for 4 ms compared to the 8 ms, the 4 ms is smallest, so taken P2 as second and 8 ms is more longer compared to 4 and 2, so taken as third. The execution order is to P3, P2, P1. As per the census in 2023 regarding to the ACM, the SJN reduces the average waiting time by 30% compared to the first come first serve. Round robin scheduling. Each process get a fixed time quantum before moving to the next process. It prevents the CPU monopolization and ensure fairly allocation. Example, the quantum time we are regarding to the round robin is 4 ms as per our requirement. The process queue is P1 is 10 ms, P2 is 6 ms and P3 is 4 ms. The execution is order is about P1 first taken as 4 ms because we have remainder 6 ms. P2 we taken as 4 ms because our quantum time is 4 ms and P3 taken as 4 ms. And for next round we have P1. P1 we have remaining 6 ms, so taken 6 ms as a second round and P2 we have only a 2 ms and taken as third round. For remaining the P1 taken as 4 and we get a remaining process of P1 is 2 ms. These are the round robin schedulings working out. The scheduling is widely used in OS and gaming to maintain the responsiveness. as per regarding to the NVIDIA in 2023. Priority scheduling. Each process is assigned a priority. Higher priority process executed first. It can be both preemptive or non-preemptive. The process queue is P1 is low, P2 is high, and P3 is medium. For firstly, we said priority scheduling is nothing but it is considered the highest priority in the first way. So P2 have highest priority, so P2 is first. P3 have medium priority, then P3 is first, second, and P1 is lowest priority, so it is third. This is used in real-time OS and embedded systems. Multi-level queuing. It is a combination of both round robin and first come first serve. For example, the foreground interactive app we use round robin and background interactive app we use first come first serve as a batch job. Multi-level feedback queues. Multi-level feedback queue is nothing but a MLF queue scheduling. It is a dynamic priority adjustment based on the CPU uses, frequently used process to move the higher priority queues. The both examples are higher priority is an interactive program, lower priority is a background tasks. Here is the shortest comparison between and first come first out and shortest job next, round robin, priority scheduling and MLFQ. The types are first come first out, non-preemptive type we used, and this is best for simple workload and weakness is long waiting time. Job first, shortest job first. We used both preemptive and non-preemptive, minimize waiting time and starvation of long process. Round robin is definitely prioritative and fair allocations, time sharing, and it is weakness is high content switchings. Priority scheduling is both preemptive and non-preemptive, critical task first, and weakness is starvation of lower priority task. MLFQ is a preemptive and it is balancing real-time and background tasks. Weakness is complex to implement. The context switching, the hidden cost of scheduling. What does mean by the context switching? The switching the CPU for one process to another process. It saves the current process states and load the next process. Frequently, as per the context switching is equal to more overhead. For example, the round robin scheduling increase the context switching compared to the FCFS. FCFS is nothing but first come first serve. Starvation and aging in the schedules. As per the previous PPT, the starvation word we mentioned, here is the explanation of starvation word is nothing but the low priority process may never execute due to the high priority task dominant CPU timings. Happens in priority scheduling and shortest job next. Solution is aging. For the starvation, the solution is aging scheduling because the gradual increasing priority of a older process it prevent the starvation and ensure the fairness. For examples, the Windows OS use a aging in its priority based CPU schedulers to get and to reduce the CPU utilization time from the dominance of highest priorities task. As per the statistics in 2023 as ACM companies, the aging prevent up to 80% of starvation issues in schedulings. Multi-core CPU schedulings. It is one of the traditional scheduling to design for a single core CPUs. The multi-core processor require a parallel scheduling strategies. The techniques used in a multi-cores are majorly three techniques: load balancing, affinity scheduling, gang scheduling. Load balancing is nothing but distributes the process across the core evenly. Affinity scheduling is nothing but assign the process to the specific core for the efficiency. Gang scheduling is nothing but gang is nothing but a group. So the group related to the process and run them together. Examples: the intercore i9 CPU use load balancing to optimize the multi-threaded applications. As per the statistics in 2023 as research in Microsoft Research, multi-core scheduling boosts the system throughputs by the 50%. CPU scheduling in cloud computing. How CPU scheduling works? How CPU scheduling works in cloud computing. Here is an explanation. The cloud computing is a cloud environment hosts multiple users and applications on a shared hardware. The dynamic scheduling ensures the fair CPU time for all virtual machines. Virtual machine is nothing but VMS. The hypervisioners manage the CPU scheduling across the multiple servers. Example: AWS EC2 uses a mixed priority scheduling on round robin. The statistics is the cloud-based CPU scheduling reduces an idle CPU time by 70% as per the statistics in 2023 in regarding to the Google Clouds. System scheduling in real-time OS. Real-time system is nothing but the RTOS. RTOS is the process must execute within the strict time constraints used in medical, automotive, aerospace industries. Its common and real-time scheduling algorithm is rate monotonic scheduling, earliest deadline scheduling. First, the rate monotonic scheduling fixed priority for an periodic task and the earliest deadline scheduling process with the nearest deadline run first. Its examples are autonomous cars used an EDF and scheduling of obstacles deductions and brakings. The obstacles deductions in an autonomous car used by an EDF schedulings. CPU scheduling in real world applications. In a real world application, the CPU scheduling is classified into four types. One is OS, cloud computing, RT systems, and game and AIs. Operating systems is used in laptops like Windows, Linux, and Microsoft for CPU and preemptive schedulers. Cloud computing in AWS, Google, cloud optimizations and CPU allocations dynamically. Real-time system is an automotive and medical device uses a priority scheduling. Gaming we use RR. RR means round robin and priority scheduling for smooth performance. The challenges in CPU scheduling. There are major challenges in CPU scheduling as contest switching overhead and starvation issue, energy consumption. These three are the major challenges in a CPU schedulings. And future trends of CPU scheduling is AI-based scheduling, quantum CPU schedulings used in parallel executions, energy efficient schedulings. They are the future trends of the CPU schedulings. What is the next for CPU schedulings is AI-based scheduling, quantum, energy efficiency. Conclusion. The CPU scheduling ensures the efficiency process execution and CPU utilizations. The different scheduling algorithm balance the fairness, speeds and efficiency. The future scheduling will be AI-driven, energy efficient and quantum based. Optimized CPU scheduling is the key to high performance computing. Thank you for watching this videos and this PPT is done for you to making sure that you are clearly understand the topic. Thank you for everyone to listen this. Thank you.